Good morning, students. As promised, the other, as I told you that in the previous class, where we discussed about the exercise of, or not the exercise rather, a revision class it was on the chapter 2, and not only chapter 2, but basically it was a combined revision class, and based on chapter 1 and chapter 2. So the questions over there. We discussed about the various the symbols, the formulas, the numericals rather. So the changes, the application of this chapter, the aspects, different aspects from this chapter, that from what sort of angle the questions can be made, new sorts of questions, applications from this chapter, how can we correlate different aspects into this particular chapter. So different from, based on that, it was basically an overall thorough revision, and it was an overall revision in comparison to a single particular topic discussion, but it was a general overall discussion revising the chapter 1 as well as chapter 2. So as in the previous class also, I told you that there was one portion of chapter 1 that has been left out, that is that is exercises of the chapter 1, which was left out. So in this second revision class, I will be discussing the exercise of chapter 1. So chapter 1 is basically having three exercises. Chapter 1 is having 3 exercises, and today I will be discussing 2 exercises. Which 2 you will definitely come to know later on when the class progresses. But only 2 exercises will be done. Why the third exercise, rather which exercise will not be discussed over here, or I will not be doing or discussing over here. So that exercise will also, the reason behind of not discussing that exercise over here, that also will be mentioned and specified. So let us continue with the exercises of chapter 1. So exercise of chapter 1, the first exercise 1A. So let's start with that. Let's start with that one. Okay. I hope it's clear. Yes, I hope you can read it from here. Let me zoom it a little bit more. All right. Now, the first question: what is a symbol? What information does it convey? The definition of the symbol is clearly given in your book. That is, a symbol of a clear definition. That's a beautifully given. A symbol is a short form that stands for the atom of a specific element, or the abbreviations used for the names of elements. That's a clear definition which is given in your book. So no problem with the first question. You can just write that this definition down, and along with that, definitely examples you have to give. So since you're giving the writing definition of a symbol, so you have to give the examples of symbols. It can be an elemental symbol, it can be a molecular symbol, not elemental symbol as a symbol of a particular compound. So I can so symbol along with the definition, that makes up complete definition. It is having a part B also. This question, that's what information does it convey. Definitely, that's this question is something you have to give basically over here. that what message does it convey? Information, that means what are the things that we can come to know from a particular symbol. So for example, that we say if you write Na, so from Na what messages we can get. So now we can conclude that Na stands for the 11th symbol, which is having atomic number 11 and mass number 23, which is having 11 protons in the nucleus of the atom, and 12 electrons, 12 neutrons in the nucleus once again, and simultaneously, since 11 protons are present, so 11 electrons are also present. If we continue to go like this way, then definitely much more information will come out. With only one particular sodium, if one particular sodium, that what more information can we get, then definitely we can go for that. Since it's 11 is the atomic number, so we can come to know about the electronic configuration, of the electrons. Electronic configuration, by the name itself, it suggests that configuration, the orientation or the arrangement of the electrons within an atom of an element is the electronic configuration. So that information is also available. It also can be derived from a particular symbol. So there are numerous information that can be derived, that can be obtained from a particular symbol. So what informations can we get? So you can list it out, or you can also get this point from your. It's also once again available in your book in the form of significance. It's given in your book as significance of a symbol. So significance of a symbol, or the importance, or what messages does it convey, for information was it convey from a symbol. All the answers are same. That means all answers will be same. So the questions are different, but answers will be same. The same question or different question, but same answer. So from a symbol, we can get the name of the element. Number 2, we can get how many atoms are present in a particular molecule of an element. From a particular, so name of the element, we will get how many atoms are present in a particular molecule of that element. Number 3, what information? The information we can get about the definite mass of an atom of an element, of that element. So nearly we can get an information about the mass of an atom of an element. So along with that, it's also we can derive. So apart from these information you will get in your book, but apart from this, you can also write that we can get information about the constituents of a particular atom, about the constituents about a particular atom is available. It can be derived from where? It can be derived from the symbol itself. Okay, all right. So this is what about question number 1. Moving to question number 2, why is the symbol S? Why is the symbol S for sulfur, but Na for sodium and Si for silicon? Okay. Now, if I go for the sulfur is the name of the element, we know that sulfur, name of the element. What about Na? The name of the element is sodium, and the name of the element is silicon. So sulfur, sodium, silicon, all three elements the name itself starts with the alphabet S. But why? The question is why aren't we, or why S is only for sulfur and why Na for sodium? The reason is, for now consider that we have used sulfur S for sulfur, and also S for sodium, and also S for silicon. So will it be easy, or will it be very fruitful for us to identify that which element we are actually going to specify? Then it will be a confusion. No, we cannot. So then it will create a lot of confusion, that which particular element we actually want to mention, and if the symbols become common, then it will be a total chaos. It will be highly difficult to difficult to understand, to clear it out, which particular element we actually want to indicate. So for that reason, the different symbols is deployed or is used for our elements having the first letter in common. Clear? Okay. Moving on to the next question. What's the full form of IUPAC? We know that it's International Union of Pure and Applied Chemists. So it's a group. It's basically an international group. It's a International Union of Pure and Applied Chemists. Name the elements represented by the following symbols. As you can see. As you can see, it's AU. AU stands for gold. PB stands for lead. SN stands for tin, and AG stands for mercury. So mercury is the final answer. Question number 4. If the symbol for cobalt is CO, written as C capital O, what would be wrong with it? Now, if the purpose of writing C capital C small o and not capital T capital O, if you write this one capital C capital O, then it will be mixed. Then the symbol will interfere with the symbol of carbon monoxide. Then we will be confused, or people will be confused to identify whether it's cobalt or whether it's carbon monoxide. In order to differentiate between cobalt and carbon monoxide, the symbolical difference has been generated. Moving on to the next question, that is, what do the following symbols stand for? H, only H stands for an atom of hydrogen. H2 stands for a molecule of hydrogen, and 2H stands for 2 atoms of hydrogen. Question number 6. What is meant by atomicity? Name a diatomic element. We have discussed previously also that atomicity means the number of atoms present in a molecule of that element. So how many atoms? So atomicity is the number of atoms present in a molecule of an element. It's called atomicity. Or molecule of a particular compound also. Whether it's a compound or whether it's an element. So the number of atoms present in a particular molecule is called atomicity. Diatomic element, you can go for nitrogen, oxygen, chlorine, everything is okay. The next question, explain the terms valency and variable valency. We have explained this term, discussed these terms previously also. Valency stands for the number of atoms, so you can write that the combining capacity of an element is called valency, or if you want to write, that is if you want to write the combining capacity, then the number of atoms, the number of electrons accepted, donated, or shared by an atom of an element in order to attain the nearest inert gas configuration for stability. This definition you can give. And the variable valency, that is the number for certain elements exhibit more than one valency. That means multiple valencies they exhibit. So such situation, such a scenario is called variable valency. Examples, of course, you have to give the iron 2 and iron 3, ferrous and ferric, or you can give for this tin also stannostanic, plumbus plumbic, so cuprous cupric. The next question, how are the elements with variable valency named? The lower valencies, the answer explained in an example. Of course, it's been given an example with variable valencies. Examples are very, very important, the compulsory rather. Now, variable valency, how that the elements of the variable valency are named. The lower valencies are termed as are used with a suffix Us, OUS. So variable valency with the elements with lower valency. So the lower valencies of a particular element is having the suffix us, OUS, and the higher valency is having the suffix ic, IC, such as cuprous, lower valency, the valency is 1, and cupric, IC, the valency is 2. So the lower valencies are having valency 1 and the higher valencies valency 2. Sorry, lower valencies are having us as a suffix and ic, and the higher valencies ic as the suffix. Give the formula and valency of aluminate. Formula and valency of aluminate. Chromate, aluminium cupric, so aluminate AlO2 minus. So this particular symbol you have to write. So aluminate is AlO2 minus, I hope so, or maybe not, sorry, it is AlO2 minus, and the valency is 1. The next is we are having chromate, CrO4 2 minus. The next we are having aluminium, Al, and the same valency is 3. The next is we are having cupric, Cu2 plus, the valency is 2. Okay, all right. The next, what's a chemical formula? It's a clear, once again, it's a clear definition given in your book. What's the definition of a chemical formula? So I'll not discuss that one right now. It's because it's a clear definition. It's given in your book that what a formula is. The next is what's the rule of writing the formula? That's also clearly the cations should come first, then the basic radicals first, followed by the acid radicals. The valencies of the top are comes to at the bottom by the crisscross method. So all these rules and regulations, all these rules are clearly given in the book. So there is no point. I don't think there is any point of discussing this one further again. So now moving on to the moving further for the next question. What do you understand by the terms acid radical and basic radicals? So acid radicals are basically negatively charged radicals. So a negatively charged species, mostly derived from the nonmetals, are called acid radicals, and basic radicals are positively charged species, mostly derived from the metal sections, are called basic radicals. And once again, if you're giving, you have to give, when you're giving these definitions, of course, you have to give the examples, of course. The next, we are having the match of the following. This one, question number 11, match of the following. Boric acid, it's H, match the following, probably it's not fully visible. So let me just zoom this one up. Yeah. Now boric acid, it's H3BO3. The next phosphoric acid is H3PO4. Nitrous acid, HNO2. Nitric acid, HNO3. Sulfurous acid, H2SO3. Sulfuric acid, H2SO4. Hydrochloric acid, HCl. Silica, SiO2. Caustic soda, it's NaOH. Caustic potash, KOH. Washing soda, Na2CO3. Dot. There is a small mistake, because small mistake, or there's specified rather. There's no mistake rather. Washing soda is sodium, and actually washing soda is hydrated sodium carbonate. Actually, washing soda is hydrated sodium carbonate. But they have mentioned that washing soda, they want to know about specifically sodium carbonate, not hydrated one. Okay, so it's it's Na2CO3, baking soda NaHCO3, limestone CaSO3, water H2O, hydrogen sulfide H2S, ammonia NH3, phosphine, it's pH3, methane, CH4. Clear, everyone? Okay. The next we're having is select the basic radicals and acid radicals over here. From there's a molecular formula. Molecular formula is given. It's MgSO4, the cations and the anions. So Mg2 plus or Mg2 plus, it's a cation, SO4 2 minus anion. NH4 whole twice SO4, it's NH4 plus cation and SO4 2 minus anion. Al2 SO4 whole twice, so Al3 plus cation and SO4 2 minus anion. Zn2 plus cation, CO3 2 minus anion. Mg2 plus cation, OH minus anion. The next set of questions, what we are having is the valency of an element A is 3 and that of element B is 2. So write the formula of the compound with a combination of A and B. So just we have to cross multiply, nothing else, the valencies. So it's A2B3. A2B3, that's a formula of the compound. Write the chemical names of the following compounds. That's first, it's calcium phosphate, K2CO3, potassium carbonate, K2MnO4, potassium permanganate. It's not permanganate, it's potassium manganate. Be careful, do not write permanganate, it's potassium manganate, K2MnO4. Mn3BO3 whole twice, manganese borate. MgHCO3 whole twice, magnesium bicarbonate. Na4FeCN whole 6, it's sodium ferrocyanide. BaClO3 whole twice, barium chlorate. Ag2SO3 silver sulfite, ITE. The next one is lead acetate, and the last one is sodium silicate. Write the basic radicals and acid radicals of the following, and then write chemical formula of these compounds. So I'm not going to discuss this one as which one is the basic radical. By the name itself, you can identify the first one is the basic radical, and the later one is the acid radical. So whatever the first name is, the first word is the basic radicals, other, and the last word and the second words are the acid radicals. Now barium sulfate, it's BaSO4. Bismuth nitrate, it's BiNO3 whole thrice. Calcium bromide, CaBr2. Ferrous sulfide, FeS. Chromium sulfate, CrSO4, Cr2SO4 whole thrice. Calcium silicate, CaSiO3. Stannic oxide, SnO2. Sodium zincate, it's NaZnO2. Na2ZnO2. Magnesium phosphate, it's Mg3PO4 whole twice. Sodium thiosulfate, Na2S2O3. Stannic phosphate, it is Sn3PO4 whole 4. Nickel bisulfate, NiHSO4 whole thrice. Whole twice. Potassium manganate, it's K2MnO4. Potassium ferrocyanide, K4FeCN6. The next question, give the names of the following compounds. Sodium hypochlorite, sodium chlorite, so NaClO, sodium hypochlorite. NaClO2, sodium chlorite, ITE. NaClO3, sodium chlorate, and NaClO4, sodium perchlorate. Complete the following statements by selecting the correct option. The formula of the compound represents a molecule, of course. The correct formula of aluminium oxide is Al2O3. The valence of nitrogen in nitrogen dioxide is 3, of course. Now moving on to the next exercise, that is 1C. So you can, by this time, so you can understand which exercise I've skipped. The reason for skipping that exercise is basically balancing reactions. So the reaction balancing, and that's an exercise. Entire exercise is about that only. So I don't think balancing a reaction I will discuss over here. So there's no point of discussing balancing. You pretty know that. If you're having any problem with balancing, you can let me know. So That I can discuss that regarding balancing an equation if there is a problem occurring. So with that I can help you out. But there is no point of discussing separately of the various balancing and what the correct answer is. You can do it by your own. Okay. Coming to exercise 1C, the fill in the blanks. Dalton used symbol for oxygen, use symbol dash for oxygen, and dash for hydrogen. So Dalton used a symbol. Then probably I should go to the book now, because which symbol Dalton used, to be honestly speaking, I have forgotten. So the same Dalton's symbols. So Dalton's symbols, I have honestly I've forgotten. So I have to go through the book then, which symbol Dalton is used. But probably, basically, maybe it's possible that it is they have used O or something like that. So maybe. H for hydrogen. The next symbol represents dash atom of an element, one atom of an element. Symbolic expression for a molecule is called formula, molecular formula. Sodium chloride has two radicals. Sodium is a basic radical, chloride is an acid radical. Valency of carbon in CH4 is 4, C2H6 is 4, C2H4 it's 4, and C2H2 that's also 4. Valence of carbon. Valence of iron in FeCl2 is 2 and FeCl3 is 3. Formula of Fe iron 3 carbonate is Fe2CO3 whole thrice. Complete the following table. It's a basic radical and acid radical, so a format is given. So the first one will be sodium chloride, it's NaCl, followed by NaNO3, Na2SO4, Na2CO3, NaOH, Na3PO4, Na3PO4. The next is ZnCl2, ZnNO3 whole twice, ZnSO4, ZnCO3, ZnOH whole twice, Zn3PO4 whole twice. The next is silver, AgCl, AgNO3, Ag2SO4, Ag2CO3, AgOH, Ag3PO4. Ammonium chloride, it's NH4Cl, NH4NO3, NH4 whole twice SO4, NH4 whole twice CO3, NH4OH, NH4 whole thrice PO4. Calcium chloride CaCl2, CaNO3 whole twice, CaSO4, CaCO3, CaOH whole twice, Ca3PO4 whole twice. Iron 2 it's given, so FeCl2, FeNO3 whole twice, FeSO4, FeCO3, FeOH whole twice, Fe3PO4 whole twice. And the last one, KCl, KNO3, K2SO4, K2CO3, KOH, and K3PO4. Moving on to the next question, that is sodium chloride reacts with silver nitrate to produce silver chloride and sodium nitrate. Write the equation. So it is NaCl plus AgNO3 gives AgCl plus NaNO3. Show whether the reaction is balanced. It's a reaction is already balanced. Weights of the reactants, you can do that. State the law, that's the equation satisfied. That's law of conservation of mass or matter. What information does the following chemical equation convey? The equation convey that metallic zinc reacts with sulfuric acid to form zinc sulfate and hydrogen gas. Zinc displaces sulfuric acid and hence it's more reactive than sulfuric acid. It's more reactive than hydrogen, and hence it's capable of displacing hydrogen from its acid to liberate hydrogen gas. Similarly, the same reason for about magnesium also. The magnesium, its metallic magnesium reacts with hydrochloric acid to form magnesium chloride and liberate hydrogen gas. And with magnesium, 2 volumes of hydrochloric acid reacts with 1 volume of magnesium, and magnesium is more reactive to displace, more powerful to displace hydrogen from its corresponding compound. Next, what are polyatomic ions? That means whether it's an acid radical or a basic radical, but mostly goes with the acid radical. An acid radical or an anion having more than multiple atoms together to form one particular molecule, an anionic molecule. Those are called polyatomic ions. For example, ClO minus, CO3 2 minus, SO4 2 minus. So all these are examples. The fundamental law that is involved in every equation, that's of course the law of conservation of mass. What's the valency of fluorine? It's 1, sulfur in SF6 is 6, phosphorus in pH3 it's 3, carbon in CH4 it's 4, nitrogen in the following compounds: N2O3 that's 3, N2O5 it's 5, NO2 that's 3, NO it's 2. Why should an equation be balanced? Of course, once again the same rule, that's otherwise it will violate the law of conservation of mass, which cannot be done. So it needs to be balanced. Now write balanced reactions or equations for the following. This one you can do it on your own. The equations you can do it on your own. Please do submit your work so that I can cross-check your answers, especially this one. And if I find any problems, so that I can let you know about your mistakes. Define atomic mass unit. Define atomic mass unit. That also it's given in your book. That is the mass of one atom. Okay, it's basically atomic mass unit is it's a unit used for as a mass of one particular atom. So atomic mass unit defined as the 1/12 the mass of carbon 12. So that is atomic mass unit. The next, calculate the molecular mass is the numericals. You have to go by the numericals itself. Choose the correct answer. Modern atomic symbols are based on the method proposed by probably Dalton or Bohr. I forgot that one. And the next of carbon atoms in a hydrogen carbonate biradical or carbon radical is 1. The formula of iron 3 sulfate is Fe3SO4 whole thrice. Fe2SO4 whole thrice. In water, the hydrogen to oxygen mass ratio is 1 is to 8. The formula of sodium carbonate is Na2CO3, and sodium calcium hydrogen carbonate is CaHCO3 whole twice. Correct the following statements. A molecular formula represents an element, of course not represents a molecular formula represents a compound. Molecular formula of water is H2O represents 2 parts of hydrogen, 9 parts of mass by water. 9 parts of mass by water. Molecular formula of water H2O represents 2 parts of hydrogen reacted with 1 part of oxygen. And a balanced equation obeys the law of conservation of mass, and so does an unbalanced equation does not. A molecule of an element is always monoatomic. No, it can be polyatomic also. CO and CO both represents cobalt, of course not. CO represents carbon monoxide, and C small o represents cobalt. Calculate the relative molecular mass. Since it's given empirical formula, empirical formula is also numerical. So that's all with the discussion of the exercises of this chapter, and with this the chapter 1 gets over and completed. Any more questions or any more further queries what you were having, so you can obviously do that through emails there, so no, not an issue. So further in future classes, the revision of this chapter will be done once again, and till then I conclude my class over here. So thank you. God bless. Stay safe.